Welcome back to the second part of the ECS tutorial using Godot 4 and Rust. We will continue our journey and therefore let's keep going. So first of all, we extend our ECS node with a new method so that we can send individual events to our previously launched task or thread where we want to do all the ECS related handling. And as an argument for this method, we actually pass a ECS event, which will later be then used to propagate properly. So we call it kind of request. So we follow this kind of request response pattern so that it's more clear for us when we send something to the ECS and we receive something from the ECS. And in order to send it, of course, we need to wrap it because that's just a request event what we share there. So that means we need to use the ECS events, a request, and then add our ECS request in it. So basically you could then invoke the method like with send ECS request, pass the proper event you want to use, and that one should be then received by this kind of thread which contains the ECS, and then execute the ECS logic, and when it's done it sends back a response what you could then in the process method cover. However, let's continue for now and let's add our resource. So the resource what we want to create first is actually a dispatch or dispatcher resource. That one should contain the information or at least kind of have access to the sender as well, so that we can send when a system has completed a message to the receiver what we just defined in the previous tutorial, and therefore we could handle these proper events in a way as we want to build up our business logic. In order that bevy is able to recognize the dispatcher resource as a real resource, we need to derive it from the resource type, which is declared inside of bevy. And in addition to that, the dispatcher resource should have actually two kind of methods. The first one, of course, is kind of a new, so where you create this new instance. And the second one would be also, as we had before in the ECS node, kind of a general method where you can send proper events through. The only difference this time is that this particular send will propagate back to the listener of the ECS itself, like this ECS task component what we created, and then will execute within there, within the loop, the proper logic. And then we can actually start propagating back to the ECS node, for example, the result, what we sent over, or so on. In order to use our dispatcher resource, of course, we need to add it to the world, what we also instantiated before. So therefore, we just say world insert, and then we use the dispatcher resource. As mentioned, we will also need to define first this kind of new method so that we initialize properly a new instance of the dispatcher resource. Of course, as an argument, we are passing the sender. And then heading back to the ECS task, and we can finally insert this kind of new resource. In order to provide the argument, of course, our new method for the ECS needs also to be extended to get the proper sender as an argument passed. In order to execute different systems, or in general systems, you need a schedule. The schedule is actually kind of the key component which will then execute all our systems as needed. In my simple tutorial, actually, I would still use a simplification kind of in sense of scheduler, but usually based on my previous experience when the application is growing, I came up with the idea to have multiple different schedulers for different tasks. Let's see how it goes from there, but basically we define now an application scheduler and move on from there, and then let's see how it goes. The scheduler itself will also have kind of a method to instantiate a new instance. And part of that will be the inner scheduler, which we will declare in the beginning, and then add our so-called systems we would like to add. So of course, the next step would be defining also the systems once the scheduler is kind of done. Also, let's get rid of the typo here. And of course, we need to return self. Then ensure that we export it again. Fix the schedule. Instead of scheduler, it should be schedule. And then, of course, we need to fix our variable name. Now let's continue to create our system folder. Again, we will have a mod.rs file inside, and then we declare the application system. And the application system will contain all the related application systems we want to use. So in the past, what I did in previous projects, I usually used the application system, for example, to have general handling of application related topics, for example, initializing, deinitializing, when the app goes in foreground or background. These kind of things I usually put in my application system. And then for the business logic case or kind of the update scenario, I have a own schedule, which is then handling a loop-based environment. Every time, every frame, it executes certain events in parallel, for example. That's just one idea. I'm not saying that's the best way, but that's something what I personally prefer. And so far, it worked out pretty well. And of course, after the whole definition in the mod files and so on, we can start to pass to the scheduler or to the schedule the proper events and attach them to it. So when adding events or systems, the cool thing about bevy is that you can chain them. So for example, you could say, I want to execute system A before something else or after something else. That makes it really nice. So for example, the dispatcher system would be when the application initialization was completed, and all the other systems related to the initialization of the system or initialization of the application would have been done. At the end, another system will be executed, which will then send the message to the ECS receiver and then propagate properly through another channel to the ECS node the message. By extending the handle request for the application will initialize, we will now use our application scheduler and execute the run method with the word as an argument. then our application systems will be executed. As previously mentioned, in the application did initialize, we will use the dispatcher resource to send back an event, like a response in that case. Therefore, we can use the bevy import again and reference from the argument the resource, dispatcher resource, and then send over an event by using dispatch. So the ECS node itself, as you can see, will receive this kind of events and handle them as well properly. Normally, the ECS node will most likely have only responses. In addition to that, we will also extend the ECS task, what we had before, with an ECS sender. So that means that we actually store both instances for the sender for now. And it's very easy to actually come over the borrow checker with this kind of channels because they can be cloned, and therefore you don't run in this kind of problems when you are accessing the variable later somewhere as well. So therefore we just use the clone here. Store the ECS sender as well. It might be even not required, but let's see later on. I'm pretty sure we will do a bit of refactoring as well at a later point in time. And that the borrow checker is also not bothering you too much. There's a neat trick. Just assign the ECS sender, for example, clone it in a other variable, like in that case I call it scoped ECS sender, and then by the move semantic you can put it inside of the closure and it will not complain. That's a neat trick. I usually use it sometimes because otherwise sometimes it's a bit tricky to have closures working properly with Rust. So that trick worked out also pretty well on my end. And then, of course, we just need to ensure that the dispatcher resource gets properly initialized now with the ECS sender. So that was a mistake before. We should not use the node sender there, the ECS sender, because we want that the system is communicating back to the ECS task instead of the ECS node. Also, let's rewrite that one instead of the receive to try receive, because the receive itself is only blocking. And then the sender we can also remove from the struct itself because it will be just referenced inside. In order to display our events with the console, for example, we implement the debug, derive for it, ensure that the ECS request and the ECS response also derive it, and then we can use kind of the Godot print methods or println, for example, to display our event in the console. Initially, I also just showed quickly when I added the system. Of course, now we need to align it and modify it a bit. So therefore, let's undo the change inside of the application scheduler and reassign the system. So what we want to use now, we want to use sets. Sets is also a very neat way where you can declare multiple systems that they can listen for specific sets and execute in parallel, for example, with those sets. So you could have multiple systems which belongs to the same set, and they will execute, for example, if they are defined within the set. So we call one now init and complete. And in our case, we only have two systems yet defined. One is like the will initialize and one will be the did initialize. But basically, you could say application is initializing database, application is initializing user profile, something like that. And you could put them both in the same application set init. And once the application set init is done, after that you execute, for example, application did initialize, which is then in the other set, let's call it in that case the complete. So that means it's the end of the run. I hope I explained it well enough. but this has really big benefits. The code structure is getting very clean. You have individual small systems, and basically you can query your components through the system or systems, which makes it really a neat way to work with Bevy and Godot, for example. It's also nice that this kind of core get almost dependency free, which is also a very neat feature because you can migrate to any kind of engine if you want. So this kind of approach in combination with Rust would work for any kind of engine, basically. The only tricky part is unfortunately sometimes matching all the proper columns and brackets, but I hope I will find it out quickly, otherwise I need to zoom out to get a better overview. As the compiler would otherwise argue, you need to ensure to derive for a system set clone equals, partial equals, debug and hash. I will also quickly zoom out, so that's the way how our application systems are now defined. Let's also heading back to the ECS task, and let's get rid of the ECS handle request, because in the ECS node we want now use the ready method to initialize or trigger an event to initialize our application will initialize event. And then in the process method where we listening for the receiver, we print out our event what we should receive. In that case, did initialize. Now let's quickly build it, run it in the Godot editor, ensure also in case you did not to reload the Godot project. And now we should see in the console our received event. I hope you enjoyed the second part of ECS and Godot. Thank you for watching. See you next time.